the velocity of the object is shown. At which of the 6 numbered points is the object moving in the positive x direction? Can you circle all that apply? And then when is it moving in the negative x direction? And at what points is it not moving? At what points is it changing its direction of motion? So this graph is v of t equals sine of 2 pi t plus 0.5. That is its formula. And just go ahead and answer for yourself what you think the answers to this one are. And then I'll give my answers as well. Okay, so one of the things we like to do in physics for this type of thing would be to find the derivative of it and the antiderivative. Now, I didn't ask that, of course, but I'm just pointing that out, that that's something we could do to better understand like what's happening in this problem, right? So I'm going to do that right now. I'm going to find the derivative of it and the antiderivative. So the antiderivative of velocity is going to be position. So x of t will be the antiderivative of the velocity function. Okay, so I'm gonna find that now. And then we'd also like to find a of t. But a of t will be the derivative of this function. So since I bring up that second question, maybe you can also do that. Can you find the derivative of this function? And then maybe even just sketch what it might look like. Just kind of freehand there. I'll give you a second to try that as well, because that would be the acceleration, it's called. Alright, so I'll find it myself and then I'll graph it myself. So we need to find d over dt of sine of 2 pi t plus 0.5. So the derivative of sine would be cosine. You know, there's this whole cycle of sines and cosines, right? So like, if your original function is sine, then its derivative would be cos. But this is a chain rule, because you have constant times t, right? So we're going to end up having cosine of 2 pi t times 2 pi. The derivative of 0.5 would be just 0. Alright, so what's that going to look like? Well, let's see. We'll have a cosine graph, so I'm just marking some important points on the graph, trying to line them up with the above. Yeah, it would hit those points. So Alright, our acceleration graph would look like this. Alright, so that's great to be able to do. But we also want to be able to find an antiderivative so that we can sketch a position graph for this object as well. We want to find the antiderivative of sine 2 pi t plus 0.5 dt. Alright, so see if you can find that antiderivative. It is a little tricky. You might have to think back to your calc experience to do that. My hint is that there's a cycle of sines, right, where sine's derivative is cosine, cosine's derivative is negative sine, and then its derivative would be negative cosine. And then what happens is you just cycle all the way back, and you just keep going around and around the circle. So since we were here for our velocity graph, that means that our acceleration graph was going to be the first derivative of sine, which is cosine. But since we're now anti-differentiating sine, we have to go back through the cycle. We have to go now up to anti-differentiate. So that's my hint. You know, it would involve negative cosine. You can try it for yourself. Alright, so to anti-differentiate this, we would either want to do it by hand using a U substitution, it's called, or we could use an online calculator to find an antiderivative. And I encourage that, you know, if you're not sure, you know, how to do it by hand. So I would just use this symbolab.com, and I'll do it using that technology here in a minute. But first we can just do it by hand real quick. You'd have to figure that sine of 2 pi t can be replaced with sine of u. And the way that this is done in calc is you just say u equals 2 pi t. Alright, you're trying to transform it into a simpler integration. And then what you do is take the derivative of that, so du over dt is 2 pi because you want the relationship between the differentials. And if I solve, I get that. But now I could plug that in. Because you have to have your variable in the integration match the differential. Du over 2 pi. Alright, so now we're going to have 1 over 2 pi times negative cosine u plus 0.5 u, and then plus c. Going to put back in what we said the definition of u was, which was 2 pi t plus 0.5 times 2 pi t plus some constant c, which I'll call an initial position, xo or xi, you could call it. All right, so if we distribute, we will have 1 over 2 pi cosine 2 pi t plus 0.5t, which is exactly what we wanted, and then plus some initial position. All right, let's try to sketch that. And oh, I should do it on Symbolab too. So let's let the calculator find it for a minute. All right, so here's symbolab.com, very powerful online calculator. We want to find what's called an indefinite integral, which doesn't have limits to it for right now. And we'll just type in our formula. All right, yeah, that looks good. Go ahead. All right, as you can see, it's got cosine. Okay, so negative 0.159 cosine of 2 pi t plus 0.5 t plus a constant. Okay, so that is good. It matches. Now we should graph it. All right, but one problem is we don't know where to start because there's this constant at the end. That'll be an initial position. So let's just say, for the sake of our example, let the initial position be 0. So the initial position at time t equals 0 is x of 0 equals 0. All right, so that's going to put our object right here at the beginning, at the center of the coordinate system. And basically, we've got, let's see, you're going to go over 1, and then up a half, and then over 1, and up another half. So you have this term, 0.5t. So that's going to be part of the graph, is this gets added to it. But other than that, it would have a cosine-like shape. So I believe that what we're looking for would be, I think it would be something like this. All right, you can go to desmos.com to graph these things. So original function, sine of 2 pi t plus 0.5, that was a velocity function. Now we want the antiderivative, which is negative 1 over 2 pi times cosine of 2 pi t plus 0.5 t. This is a position function. This program sometimes doesn't understand the physics interpretation of things. It's like looking for the mathematical interpretation. So when I put in x, it literally thinks that's the horizontal variable. So I'm going to use y instead. That's much better. Did not expect that. But okay, that's what we're looking for, yeah. Because our function couldn't overlap itself, couldn't be in two different positions at the same time, so this would be wrong. This is right. Good. All right, now that we fixed that, yeah, it looks pretty good there. All right, so At which of the 6 numbered points is this object moving in the positive x direction? So we're looking for times when the velocity is positive. If the velocity is positive, then it's moving forward. It's moving in the positive x direction. So which way is the positive x direction? That's this way. All right, so at point 1, you would actually have to say yes. The object is moving forward at the first point here because of its velocity being positive, like it's off the axis, you know? So it's moving forward. Now if we zoom in on our antiderivative, on our antiderivative, we see that this would be 0.1. And notice how the slope, is it negative, positive, or 0? It's slightly positive. And that is another way to interpret that this thing is moving forward. All right, if we check out point 2. Point 2 lines up with, right about here. This is going to be point 2. So is it moving forward? Absolutely. We also see that the height off the graph of the velocity is really high, which means it's actually when it's moving fastest. So we want to interpret like fastest motion as in 2 different ways. For the position graph, it's all about the slope. If your slope is steep, then you're moving really fast. But when it comes to the velocity graph, what we mean by fastness is how far away it is from the time axis. So you just always want to be aware of like what motion graph you're looking at and what does it mean, you know. What about 3? Is it moving in the positive x direction at point 3? That would be right about here. I would say yes. So I would circle that. What about 4 though? We're talking about this point right here. Something special happens there. It has what's called a stationary point. A point where the tangent line to the graph would be horizontal. See that? So it's neither sloped up nor down at that point. It would be actually changing direction at point 4. And it would be stopped just for an instant. So I won't circle point 4. And finally, what about point 5? Would point 5 be moving forward or backward? That would be this point here. Here our slope is negative. So our object is actually moving backwards at that time. So I won't circle that one. So this is moving back. And then at point 6, it's actually just it's going to be moving forward again. So I will circle that one. And for B, we'll now say that it was moving backward at 0.5. It was not moving at 0.4. And at which points is it changing the direction of motion? That would be 0.4.